So first thing we're going to be working on today is your axis of symmetry formula. So we're going to actually skip over this first part. We don't need to do that. So this right here, x equals negative b over 2a. That is our axis of symmetry formula. So what's going to happen is there's going to be situations when you can't just look in your calculator and find your axis of symmetry, which let's recall, where is our axis of symmetry? Do you remember? It's that imaginary line that goes right through the middle of the parabola. Remember, symmetry means it breaks it up so that it's the same on both sides. It always goes through your vertex. It's always a vertical line. We always represent it with a dash line there because it's imaginary. So our axis of symmetry, it's used for a lot of different things. It's used a lot in word problems, which we're going to do a few on the back. It's used a lot because it's not always going to be a nice axis of symmetry. Sometimes it's a decimal. Our calculators aren't set up for decimals right now, although we could change that also. Other thing, hopefully you remember about your axis of symmetry is it's always halfway between your roots. So that's my root 1, my root 2. My axis of symmetry is always going to be exactly halfway between it. So whether it's 1 unit away, 1,000,000 units away, axis of symmetry is always going to be right in the middle. So what we're going to do down here is we're going to practice finding our axis of symmetry algebraically. So in order to do that, first thing you need to do is make sure that your equations are in standard form. Does anybody remember what standard form is? No, we have a lot of studying to do before Friday. Standard form means your largest exponent goes first. So our largest exponent here would be x squared. So it's got to be our x squared term, and then our x term, and then our number, which we also refer to as our constant. And then the letters representing your coefficients just go in order, A, B, and C. So if we look at our first example here under letter A, what would be our A value from the equation? 2. Because it's in front of your x squared term. A is always in front of your x squared. Where's our B term? 8. B is in front of x. A, B. So then our formula here, x equals, it's got this negative sign, so I'm going to put negative, and then my B value, so negative 8 over 2 times A, so over 2 times 2. So what is 2 times 2? 8 divided by 4? You can get a negative 2. So x equals negative 2. That would be our axis of symmetry. That would be the middle. The equation. Right here. All right, let's look at letter B. What is our A value? Negative 3. Our B value? 6. So now I'm going to plug it into the formula again. So x equals negative B. So I'm going to put my negative 6 there. Over 2 times my A value. So over 2 times my negative 3. That gives me negative 6 over negative 6, which would be 1. So the equation for the axis of symmetry for that one is just simply going to be x equals 1. All right, let's try our third one. What's our A? What's our B? And negative 4. So then again, plugging in, so x equals, we have negative from the equation, and we're also plugging in a negative 4 this time. over 2 times my a, which is a 1/2. So what happens to our 4 if I have negative, negative? Turns it positive. And then what's 2 times 1/2? 1. So 4 divided by 1 gives us an axis of symmetry of x equals 4. All right, so let's keep going. Exercise number 3. They want to know what are the coordinates of the vertex of the parabola given there. Is the vertex a maximum or a minimum point? So let's actually answer that question first. So this equation here, will it open up or down? Up. Because it is a positive x squared term, so this is going to be opening up. So is this going to be a minimum or a maximum? Minimum. So I got that part done. So let's go ahead and figure out the vertex. So in order to figure out the vertex, you have to start with your axis of symmetry. Remember, axis of symmetry always goes through your vertex. So we start with our x equals negative b over 2a, and that's going to give us the x value of your vertex. So what is our b value in our equation? Negative 6. What is our a value? A is in front of x squared. 1 is there. We don't always write it, but it is in fact there. So this makes this plus 6 up top, so we had minus a negative. So what's 6 divided by 2? 3. So our axis of symmetry is a 3, but also when it comes to writing out our vertex, we now have the x portion of it. There's going to be 3 something. We just have to figure out what that something is. Does anybody have a guess as to how we could figure out the y part? Plug in what we just got for x, yeah. 3 squared minus 6 times 3 plus 10. What do we get for that? 3 squared minus 6 times 3 plus 10. Well, what is 3 squared? 9. 6 times 3? 18. 1 plus 10. So yeah. 9 minus 18 is negative 9, plus 10 gives us a 1. So our vertex would be the point 3, 1. Let's try it again for this next one. What are the coordinates of the vertex of the parabola with the equation y equals negative 4x squared plus 2x minus 5? Is the vertex a max or a min point? So let's answer that part first again. What kind of parabola would this be, up or down? Down, because this is a negative. So our parabola would be going this way, so we would have a maximum point. So our vertex this time is a maximum. So again, to figure out the coordinates of the vertex, we've got to start with the axis of symmetry because they share that value. So what is our b value? 2. Yep. So we got the negative from the equation and then the 2. Our a value is a negative 4. So what's 2 times negative 4? Negative 8. So we got negative 2 divided by negative 8. What are we going to get? One-fourth, or you could use it as 0.25. So then we'll plug that in. So plug in my 0.25. Let's have you type that in your calculator, see what we get. give you a hint, it's going to be another decimal. Anybody? -4.75. So there's the rest of our vertex. So sometimes the vertex is a decimal. As I said, our calculators right now are set to go up by ones in your table, so you wouldn't always see your decimal. All right, so let's get into a couple of word problems. So, exercise 5, the number of bacteria in a culture after T hours is modeled by this equation here. After how many hours does the culture attain its maximum size? So, these word problems are a little different than the other ones we've been doing. If I were to graph this, I'd have a parabola that looks like this. I know it's downwards because it's negative out in front. So it's got a maximum value here. So our maximum value is comprised of two numbers. The y portion of it would be the number of bacteria. And then the x portion of it would be the when. When does it get to that point? When does it reach its maximum bacteria? Or if I was looking at this point, when does it get to that point? When does it get back to 0? So your x is always your when, your time, if it ever has it. This one has a time, definitely. So they want us to figure out after how many hours does the culture attain its maximum height. So since it talked about its, or not height, maximum size, it's talking about maximum. That means it's talking about your vertex. Anytime it says maximum or minimum, that means it's talking about your vertex. So what part of the vertex do we want? Do we want the x or do we want the y? Does it ask us how many is our maximum? No, it asked us when. We want the x portion of it. So to figure out that, it's the same formula we've been using. X equals negative b over 2a. If you want the x portion of your vertex, the x portion of your max or your min, it's negative b over 2a. But instead of x, what letter are they using? They're using a t. Really, we just kind of have to make that t equals. So what's our b value? Yep, so negative 408 over 2 times negative 2. And what does that give us? Ends up being negative 408 divided by negative 4. What do we get? 102. And that's hours. They told us up here T hours, so it's in hours. And again, they didn't want to know what the maximum size is, just when does it reach its maximum size. So 102 hours, which that's just over 4 days. 4 days is 96 hours, so just over 4 days. Let's try another one. They love to ask these kinds of questions, and I find it very frustrating. The revenue received for selling X cell phones at a technology shop is given by this formula. How many cell phones must be sold at the shop to obtain the maximum revenue? And then what is the maximum revenue? The thing I find frustrating is them using the word revenue. I mean, come on, you guys are freshmen. Should you really know all these business terms like revenue and whatnot? No. Revenue is just kind of like your profit. So, I mean, it's not exactly the same. There is a little bit more technicality to it, but all you need to know is it's pretty much like your profit, so it's money. Revenue is money. So again, if I draw this parabola, it's going to be going this way. So it has a maximum. Here's our vertex. It's a maximum. So this time, though, does it really talk about a time? No. It talks about revenue, which is your y value. And then to get your revenue, you have to know how many phones you are selling. So that is your x, because your cell phones is independent and it controls your revenue. So the one that controls the other one is your x. The number of cell phones is their x. So they want to know first how many cell phones must be sold. So we got to find our x. And then what is the maximum revenue for that many of cell phones being sold. Either way, still dealing with our vertex. So that means I'm doing negative b over 2a first. Whenever we're dealing with vertex, it's negative b over 2a. So what's our b value? 110. A value, negative 0.5. So what do we end up getting? What's 2 times 0.5? 1. So negative 110 divided by negative 1? 110. So 110 cell phones. That answers the first question of how many cell phones will give them their maximum revenue. 110. So now what we do is take our 110, plug it in to figure out what is the amount that they're going to get. So negative 0.5 times 110 squared plus 110 times 110 minus 36. So just plug in 110 in for our x. So go ahead, type that in your calculator. Let's see what we get as our maximum revenue. Anybody got it yet? 6,014. That's going to be their maximum revenue. We need to write the equation in standard form. We've done some writing the equation in vertex form. So this time we're going to switch it up, do some writing the equation in standard form. So just as review and practice, let's have you factor and solve that quadratic right there. So hopefully you ended up with x equals 2 and x equals 1. When it factored, signs would have been the same because it's a positive at the end, both negatives, it's a negative in the middle. Multiplies to 2 is 1 times 2, adds to give you 3 is the 1 plus 2. Remember, middle is always that check. So what we're going to do is we're going to be going backwards. This time we're going to know the answers, we're going to know the roots, and we have to work ourselves back up to get to the equation. So all you have to remember, again, these roots here, when they're in factored form, the signs are different. So we're just going to take the roots, put them back into the parentheses, and then multiply everything out. That's how we come up with our equation here. So here I wrote out the steps if you need it. Step 1, identify the zeros. A lot of times they're already given them to you. If it's on a graph, all you simply have to do is look at the graph and figure out where are my 2 zeros. Where does it hit the x-axis there? So then the next step is you're going to set up 2 sets of parentheses. Because remember, we are doing our backwards factoring. One tricky part about this, though, is what those 2 parentheses are equal to. you would set up your parentheses. It will equal 0 if there's no graph. So if they just tell you, write the equation with the roots of blah, blah, and blah, blah, you set it equal to 0. However, if you are given a graph, it's going to equal y or f of x. It would be f of x if they specifically said write the function rule. Then you have to use function notation. It would be y if they just said write the equation. So after you do that, what you would do is you would take your roots, plug them into your parentheses. So like here we have roots of positive 3 and positive 6. But remember, when we put them into the parentheses, we have to change our sign values. So we would plug them in as negative 3 and negative 6. Again, it's just this backwards. Remember, we took these. They're the opposite of the factored form. So now we're doing that also. So once you have that, then you multiply everything out. So x times x gives me x squared. X times negative 6 is going to give me a negative 6x. Negative 3 times x is a negative 3x. Negative 3 times 6 gives me a positive 18. So you use your double distributive, multiply them out, combine your like terms, and then there's your equation. So we got 4 examples that we're going to try for it. So number 1 says write the equation of the quadratic with the given roots, x equals 3 and x equals negative 4. So I'm going to set up my 2 sets of parentheses. I don't have a graph for this example, so I'm going to set it equal to 0. I have my roots, so when I plug my roots back into the parentheses, I'm going to change their signs. So that's going to become an x minus 3 and then an x plus 4. And then go ahead and multiply it out. I'll give you a minute to practice that multiplying skill. Alright, so that's what you should end up with your equation as being x squared plus 1x minus 12 equals 0. So after you multiply it out, combine all your terms, that's what we should get. So looking at number 2, they want us to write the function rule for the quadratic given, or quadratic below with the given roots. So first off, what are those 2 roots? Negative 2 and 3. So if you're given a graph, you have to make sure you identify what actually are your roots first. So then I'm going to set up my 2 sets of parentheses. And because they told me to write the function rule, I'm going to set it equal to f of x. When I plug in my roots, they're going to change in sign values. So x plus 2 and then x minus 3. And then go ahead, let's have you multiply those out. Multiply. Let's see. So that's what your equation should be. X squared minus x minus 6 equals f of x. All right, 2 more examples. So number 3, write the equation of the quadratic below with its given roots. What's different about this graph than the other graph? Which way is this one opening? Down. So I'm going to set up my 2 sets of parentheses. They told me just simply to write the equation, so I don't have to set it equal to f of x. I can set it equal to y. But because it's opening down, I'm going to put that negative 1 out in front. Remember, that negative means that it's going to be opening downwards. So what are our 2 roots on that graph? -1 and -4. So that means they're going to become +1 and +4 in your parentheses. Now for this one, when you multiply it out, keep the -1 out in front. Take care of that last. And then follow the same multiplying steps you've been doing before. So x times x times 4, 1 times x, and then 1 times 4. What does this 4x plus 1x give us? 5x. So now I'm going to distribute my -1 through. So that gives me -x squared minus 5x minus 4 equals y. Remember, whenever it says you have to have an equation, you need to make sure there's an equal something there. Last one, write the equation of the quadratic with the given roots. The downward opening parabola, so that means I'm going to put that -1 in front. And then I have roots at -7 and -2. No graph this time, so I'm going to set it equal to 0. And so then it becomes +7 and +2 inside those parentheses. And then go ahead and multiply it out. There's what you should end up with. -x squared minus 9x minus 14 equals 0.